so again, today we're going to be doing synthetic division of polynomials. So yesterday we did long division of polynomials, okay? And we can only apply this method, the synthetic division of polynomials, when the divisor is x minus b, or when the divisor has only how many terms? Two. Has only two terms. Okay? Again, if it's more than one term, more than two terms, let's say 3 or 4 in your divisor, then you have to use the long division. Okay? All right, so here are the steps. And we're going to use this example for number 1, x cubed plus 5x squared minus x minus 9 divided by x plus 2. And then we're going to follow all these steps. All right? Okay, now the first step is to write the k for the divisor. Okay? So just like when you use the remainder theorem, we're going to solve for x, right? And that's your k in this part. So what's the x value here? -2. So if you solve for x, right, x plus 2 equals 0, and so x equals -2. And so basically that's your k, and that's the number you're going to put in this operation. So this is going to be the symbol for synthetic division, okay? So you put the -2 inside there. And then after that, after you identify the k, you're going to write the coefficients of the dividend. You're going to list down the coefficients of the dividend. So this is something easier because you don't have to deal with variables. Okay? So just the coefficients. So what are the coefficients? We have 1, 5, -1, okay? And -9. And remember, if you have a missing term, you're going to put a placeholder which is 0 to the coefficient. But in this, we don't have a missing term from the x cubed. And then after we write down the coefficients of the dividend, we're going to bring the leading coefficient down. Okay? So we're going to leave a space here for our work, and we're going to bring this down, the leading coefficient. Okay, leave a space here and then put the line. This part will be where we put our work, okay? And so we're going to bring down 1. And then after that, we're going to multiply the leading coefficient, that 1 that we bring down, by the k value. And we know the k value in this polynomial is -2, right? So multiply -2 times 1, that is -2. And then, now the good thing here is the operation is addition. Okay, unlike your long division, we're going to subtract the term. Sometimes students get confused when they subtract because they always forget when you have to change the sign. Right here, you don't have to because you just have to add the numbers. So that's 5 plus -2. What is that? That's 3. And once you get the sum at the bottom, you're going to multiply the result by the k again and then repeat the process. Okay? So that's -2 times 3 is -6. And then you add -1 plus -6, -7. So
you just carry down the first part.
Yes, the first coefficient. And then -2 times -7 is +14. And then -9 plus 14 is 5. So now these coefficients at the bottom, we're going to use this to write out our quotient, okay? But the resultant, just remember, the resultant polynomial will be 1 order less than the dividend of the polynomial. So if we know the degree of the dividend is what? What is the degree of the dividend? This is degree 3. And so the answer, the quotient, will be 1 less, right? Because we're dividing this by x. And so the leading term will have an exponent of 2. That's 3 minus 1. Okay, so this is degree 2. Okay, so when we write out our answer, we know that the leading term, the first number here, will be x to the power of 2 because that should be degree 2. And then the next coefficient will have the x term. The next one will be the constant. And then the last one will be your remainder. Okay, and so the final answer would be 1x squared, so I can write that as x squared, plus positive 3x, so plus 3x. And then the constant is -7, so -7. And then the last number will always be the remainder. So the remainder is 5. So you can write positive 5 over the entire divisor, which is x plus 2. And this is now your quotient using the synthetic division method. Okay? You can try using a long division method and check whether you will get the same answer. You will get the same answer. Okay? All right.
Wait, don't just leave that. Don't move on yet.
Would that be easier?
No.
Okay? This method is new to most of you, so you just have to get familiar with this method. Again, this can only be applied when your divisor is only 2 terms. If it's more than more than 2, like 3 or 4, you cannot do synthetic division. Okay. Now let's try this one, number 2. X cubed plus 7x squared plus 15x plus 9 divided by x plus 1. What is your k value? -1. So we're going to place -1 inside. And we're going to list down the coefficients of the dividend. What are the coefficients? So 1, x cubed is a coefficient of 1, 7, 15, and 9. And leave a space here for your work. Okay? Are paying attention? Okay, now what are we going to do first once we have listed down the coefficients? You're going to close your Chromebook. We're not using your Chromebook now. If you're not using your Chromebook for Math 3, close your Chromebook. Okay, so the first thing we have to do is we're going to bring down the leading coefficient, which is 1. And again, we're going to multiply this by the k value. What is that? Yes. So -1 times 1 is -1. And then we're going to add, so the operation here is addition. So 7 plus -1 is 6. And then multiply, -1 is 6, -6. 15 plus -6 is 9. And multiply again, -1 times 9 is -9. And 9 plus -9 is 0. So that means the remainder is 0. Okay? So again, the given polynomial in your dividend is degree 3. Okay? So make sure you know this. This is degree 3. And so your answer will be -1 from the degree, right? So your answer will be degree 2.
What do you multiply the k value by?
Say again?
What do you multiply the k value by?
Multiply the k value by the numbers at the bottom. So it's like so you're going to bring down the leading coefficient first, right? Okay, so that's 1. You multiply this one by the k value. And then you put the product under the next column. Okay? Yes. All right, so therefore, again, the leading term will have degree of 2, x to the power of 2. This is your x, this is your constant, and again, this is your remainder. So every time when you do synthetic division, the last number there is always the remainder. Okay? At the very right side. Okay? All right, so what's going to be our final answer? X squared, 1x squared plus 6x plus 9. We don't have to write the fraction form because we know the remainder is 0. 0 divided by x plus 1 is just 0. Okay? So therefore, this is our quotient. Okay? Any question? Okay. Now, this is very important because, again, in your classwork, you have missing terms in your polynomial. So make sure you have to know that, right? You know that if you have a missing term, you have to put a placeholder, which is 0 to the missing term. Okay? So now, what is your k value here? -1. And then we're going to list out the coefficients. This is 2x cubed plus 4x minus 8, right? What is the missing term in this polynomial? Is the x squared term. Yes, we don't have x squared term here. So I can write this as 2x cubed plus 0x squared plus 4x minus 8. Now, this is the common problem, the common error of some students. I can see on the homework from the long division method, some of you were not able to put a placeholder. Okay, it's gonna mess up everything if you don't have this. All right. So I'm gonna list down 2, 0, 4, negative 8.
Can you give us our homework back?
Later. Okay, so 2, 0, 4, negative 8. And then you do that. Okay. So we're going to bring down or drop the leading coefficient, which is 2. And then we multiply. Negative 1 times 2 is negative 2. And 0 plus negative 2 is negative 2. And then negative 1 times negative 2 is positive 2. 4 plus 2 is 6. Negative 1 times 6 is negative 6. Right? And then negative 8 plus negative 6. Yeah, negative 14. Any question? Do we have the same numbers? Okay. So this one is degree 3. So this one will have degree of 2, right? So this is x squared. This is x. This is your constant. This is your remainder. Okay. So what's going to be our final answer?
So I'm just going to put
2. So 2x squared minus 2x plus 6. Now, since the remainder is negative 14, I can write that as minus 14, or we can do plus negative 14, that's fine. But again, if it's negative, you can just do minus instead of plus. Okay, so minus 14 all over x plus 1. Okay, and last example for this part, we're just going to do this together, okay? Now, number 4, what is the k value? It's not negative 7. Negative 1, yes. So every time we have this, because we have a 7 to your coefficient of x, right? Right? So therefore, if we're gonna solve this, it's gonna be negative 7 divided by 7. So x equals negative 1. Just to show this part, okay, that's gonna be 7x equals negative 7. So divide both sides by 7. So x would be negative 1, right? So therefore, we're gonna put negative 1 inside this. And do we have a missing term? Yes. What is the missing term? The x is missing. Okay, so I can write this as 42x squared plus 0x minus 33. So I'm going to write this down 42, 0, then negative 33. If you forgot to put, because that's degree 2. It doesn't have to be always cubed. So degree 2, the answer will be degree 1. Right? Always, whenever it's a degree minus 1. All right, so we're going to bring down the leading coefficient, which is 42. And then we multiply that by negative 1. What is that? Negative 42. And then 0 plus negative 42 is same, negative 42. And then negative 1 times negative 42 is positive 42. And then negative 33 plus 42 is 9. Okay? Now, if you forgot to put a 0 here, it's going to mess up this part. Okay? So make sure you have a placeholder. Okay. Now, since the given polynomial is degree 2, again, it's always minus 1 for the answer, right? So therefore, the answer will be degree 1. So you're going to start with x, not x squared. Okay? So the 42 will be x. Your negative 42 will be your constant. And the 9 is your remainder. Okay? So what's the final answer?
42x minus 42 plus
9 over 7x plus 7. Okay, that's correct. So 42x minus 42 plus 9 over 7x plus 7. Any question? It's easier, right? But again, you can only use this with 2 terms in your divisor. All right, so for part 2, this is a common problem that we see in the release questions in the EOC. So some of the questions might be this, right? All right. Now determine, so this one is, we're going to determine the k value so that the function h of x equals 2x cubed plus 5x squared plus kx minus 16 has the binomial factor of x minus 2. Okay? How do we set this up? We can use synthetic division, but remember, if we know, if we're going to say that this factor x minus 2 is, this x minus 2 is a factor of this polynomial, then therefore the remainder must be 0, using the factor theorem, right? Make sense? So that we can say that x minus 2 is a factor, the remainder must be 0. Okay? So we're going to use synthetic division here. And then at the last part, we're going to put 0 as our remainder to solve for the k value. Okay? To solve for this value, the coefficient of x. Okay, so if that's x minus 2 as your factor, what should be the number that we're going to put inside? Is 2. Okay? And then we're going to list down the coefficients of the dividend. So what are the coefficients? We got 2, 5, 1, 5. What is this? It's just k. So just write k because we don't know. We're gonna find that value, the coefficient of x. Okay? And then negative 16. Okay? Make sense? Okay. And then we know that we're going to bring down the leading coefficient, which is 2, and multiply 2 times 2 is 4. And then 5 plus 4 is 9. And then 2 times 9 is 18. Okay? Now, what is that? We cannot combine, because k is a known, we have to solve for that value. K plus 18, yes. So k plus 18. K plus 18, we're not solving yet. Okay, we're going to continue this part. So if this is k plus 18, because we're adding whatever is the number there, plus this, plus 36. Yes, so we're going to multiply this by 2 so that we know what to put in here, right? So this 2 times k plus 18 is going to be 2k plus 36. Okay? And we know the last part, for us to know that this is going to be a factor, the remainder must be 0. Right? So if we're going to add this and set it equal to 0, then we can solve for k. Okay? All right, so what is that? I'm just going to show negative 16 plus 2k plus 36 equals 0. Okay, because we have to add this, and the remainder must be 0 for us to say that this is a factor. Okay, so what is this? 10. So 2k plus 10 equals 0. And then you solve for k. Okay. 20. Okay, so that's 20, not 10. All right, so, but you already figured out the answer, right? Yeah, the answer is actually negative 10. Okay, so that's going to be what? 2k equals negative 20. So if you divide by 2, so k equals negative 10. Okay. All right. So therefore, since k is negative 10, what will be the complete polynomial? But we're only asked to write the k. This is fine. Okay? But again, if you're asked to complete the polynomial, then the polynomial would be what? H of x equals 2x cubed plus 5x squared minus 10x minus 16. Would it be?
No, no. The
Yeah.
first one. It'd be 8, not minus 10.
Don't you have to finish it by adding the 18?
Yeah, and then negative 8. So you add the 18 using the negative 10. And
We're
then
doing the original one, not the new one.
What's your question? So we got k plus 18, right? We multiply that by 2. That's why you got 2k plus 36.
Oh, so we're just trying to find the original equation.
Yes. Yeah, I just put in the negative 10.
We're not trying to find it.
Any question? Other questions? So once we get the value of k, we can now complete the polynomial, okay? Because we're trying to find the missing number, the missing coefficient. Okay. Now, so for number 2, yeah, sure. I want you to do number 2 and try to find or complete this polynomial by solving the value of k.